Hello, I'm Lucia Chavez. I'm Mexican. I moved long time ago for my postdoctoral studies. I studied biochemistry in Mexico and did my PhD studies there. So I am interested in neurosciences broadly and specifically in the molecular basis of dementia, how Alzheimer's disease progresses. Well, I'm a curious person, and I think that curiosity in me triggered my will to do studies in sciences, so I could answer my questions. My research focuses on Alzheimer's disease, but also on amyloid positive, so people that had amyloid in the brain but did not develop dementia. So we are studying these two types of patients with dementia and amyloid in the brain, and people with amyloid in the brain but not dementia. And the question that we ask is, what are the key differentiating factors between these two types of patients, and with the aim of understanding what could be the factor or factors that play in toxicity, amyloid-driven toxicity, leading to neurodegeneration and Alzheimer's disease. I think our preliminary data shows that amyloid in demented versus non-demented cases is not the same type of amyloid. So we did single plaque analysis, and we observed that the most common amyloid beta 42, which has been studied for decades and has been actually pointed as the culprit of the disease, is not a differentiator between the demented and non-demented brains, but a different amyloid 38. So the aggregation of this peptide in plaques is seen in Alzheimer's disease samples, but not commonly seen in the non-demented samples. And in addition to that, the amyloid plaques not only differentiate in the concentration or in the type of amyloid, also the lipid content of these plaques seems to be different. And we would like to know more about how these differences in lipids play in regarding toxicity. I think at the moment, most of the studies centered in amyloid toxicity. Our studies will be mostly centered in understanding how we could naturally, people that have amyloid in their brains are protected against. So I think we could get insights into resilience or mechanisms of resilience in Alzheimer's disease to protect us, basically. So I would like to thank the Alzheimer's organization for the continued support of our science, and also the donors that make this possible.